Welcome back to tutorial series. In the previous videos, we have learned on how to find solutions of differential equations. Now let's learn how to find solutions when you have a system of linear differential equations. The combination of two or more than two differential equations is called system of linear differential equations. So you have a system now. So let's say the two equations which we take for sample are dx by dt is equal to a1 of tx plus b1 of ty plus f1 of t. So the other one is dy by dt which is equal to a2 of tx plus b2 of ty is equal to f2 of t. If these two f1 and f2 are 0, then you call the system to be homogeneous. If not, they are non-homogeneous. You can solve such equations using two methods. One is matrix method and the other one is diagonalization method. Let's check out these two methods now. Here's the matrix method. Let's consider that the system has three equations, three differential equations. So you have the terms in terms of x1, x2 and x3 and their corresponding terms is a11, a12, a13. The coefficients are a11, a12, a13. They are in this format and the functions are f1 of t, f2 of t and f3 of t. So how do we solve these to find x1, x2 and x3? Here's the procedure. You can see that we can write the above system as d by dt of x1, x2, x3 because all these are first order differentiation of x1, x2 and x3 which is equal to, as we solve equations like equations in three variables, we write them in the matrix format. We are following the same procedure here. So we have a11, a12, a13 and everything in the matrix format, and you have x1, x2, x3 written here, plus you have the functions f1 of t, f2 of t and f3 of t. So if you observe, you can write this in a generalized format like x dash is equal to ax plus f. So the general solution of the system is given by, as usual, complementary function plus particular integral. Now, here's the rule for finding complementary function. The first step is to find eigenvalues and eigenvectors of matrix A. How do you find eigenvalues and eigenvectors? We learned all that in the second module, which is the matrix module. We're following the same format here. If eigenvalues and eigenvectors are distinct, then the format you have to follow is C1 x1 e to the power of lambda 1t plus C2 x2 e to the power of lambda 2t plus C3 x3 e to the power of lambda 3t, where lambda 1, lambda 2 and lambda 3 are the eigenvalues. If eigenvalues are repeated, say lambda 1 and lambda 2 are repeated, then the solution will be of the form x is equal to C1 x1 e to the power of lambda 1t plus C2 x2 e to the power of lambda 1t. Now if we get only one eigenvector, say for example all your eigenvalues are producing the same eigenvector, then we find the second eigenvector by following this format, that is a minus lambda 1i into x2 is equal to x1. Applying this, you find the second eigenvector which is x2. When you find the second eigenvector x2 using this formula, you have to follow this format. X is equal to c1 x1 e to the power of lambda 1t plus c2 into x1t plus x2 into e to the power of lambda 1t. So to find your particular integral, it's obvious. I mean, the general format of finding using undetermined coefficients method can be followed here also. Let's solve an example. So the question is dx1 by dt is equal to 6x1t plus x2t, and the second equation is dx2 by dt which is equal to 4x1t plus 3x2t. Now you have these in the form of differentiation. So d by dt of x1, x2 is equal to 4, 1, 6, 1, 4, 3 in the form of your matrix and into x1 plus x1, x2. This relation is homogeneous because you have the functions to be 0. So this is of the format x dash is equal to ax. Now you have to find eigenvalues and eigenvectors. So as you can recall, a minus lambda I is equal to 0 is the formula. And substituting, we get that the eigenvalues are 2 and 7. From eigenvalues, when you try to find eigenvectors, you get 1 minus 4 as the first eigenvector, 1 and 1 as the second eigenvector. On applying the general method, you get c1 x1 e to the power of 2t plus c2 x2 e to the power of 7t. So this is given by c1 1 by minus 4 into e to the power of 2t plus c2 1 e to the power of 7t. Since f is equal to 0, we don't have to find the particular integral. That is, complementary function is enough to find the solution for this set of or for this system of differential equations. So the general solution turned out to be x1 x2 is equal to c1 e to the power of 2t plus c2 e to the power of 7t and minus 4c1 e to the power of 2t plus c2 e to the power of 7t. So these are your general solutions you obtain. Let's check out another question. Find general solution of systems x1 dash is equal to 6x1 plus x2 plus 60, 6x2 dash is equal to 4x1 plus 3x2 minus 10t plus 4. Here you can observe that these are similar to the previous question, but you have a few functions here. So this is not homogeneous format. As you obtained from the previous method, these are your general solutions. The only task is to find the particular solution. Let's do that here. As we know that we'll be able to apply undetermined coefficients method. So since both are in this form, you can apply, these are linear form. So the trial matrix will be AT plus B and CD plus D. So because the functions are of this format, and they're not equal to 0. So the differentiation xp dash is equal to A and C, because you get the differentiation of these are A and C. So this is a general format, that is d by dt of x1 x2 is equal to C 6143 x1 x2 plus 60 and minus 10t plus 4. On substituting in the particular respective places, you have xp in the place of x dash, you substitute xp dash. In the place of x, you substitute this xp. Now you have this format. Now on adding all the matrices, because they are of the same order, you'll be able to add the values of matrices. So you get AC is equal to this set. Now A is now you have like A is equal to 6A plus C plus 6 into T plus 6B plus D. Then you have C is equal to the corresponding terms. Now when you take A to the other side and try to solve, you get the other side to be 0. Now 6A plus C plus 6 is equal to 0. 6B plus D minus A is also equal to 0. Similarly, these two terms are also equal to 0. When you solve the four equations, you get A is equal to minus 2, B is equal to minus 4 by 7, C is equal to 6 and D is equal to 10 by 7. On substituting all these here, you get this as the particular integral. Now the solution is given by complementary function plus particular integral. On adding all these, you get this format. And now you combine all these, and in the end you get these two as your equations. C1 e to the power of 2t plus C2 e to the power of 7t. Then you have minus 2t minus 4 by 7. The next equation is C1 e to the power of 2t plus C2 e to the power of 7t plus 6t plus 10 by 7. Sorry, there's a mistake. So it is minus 4c1 e to the power of 2t plus c2 e to the power of 7t, and then you have your particular integral. So these are your solutions. Here are a few exercise problems. You can practice those to get better clarity. You have the solutions too. There you can verify. Thank you.